Hello and welcome. We are looking at example number 1, dealing with equations that involve fractions, right? So when we talk about our quadratic strategy, ideally we don't want fractions involved. And so how do we do that? We apply what we call the LCD, or the lowest common denominator. And the purpose of the LCD is to eliminate fractions, right? Now when do we eliminate fractions? When we're dealing with an equation. When we apply the LCD, however, in a case where we have an expression, remember there's a distinct difference between an expression and an equation. When we apply the LCD to an expression, we find that we turn many fractions into one fraction. However, the case is when it's an equation, we simply eliminate the fractions, right? So let's look at what the LCD looks like over here. Remember that these are linear factors or expressions in the denominator, and my LCD would look something like this. It's going to be x plus 1 multiplied by 1, which remains x plus 1, and then multiplied by x minus 1. Okay, so how do I do this? Well, I now simply take every term and multiply it by the LCD. So if I had to take the first term, 1 over x plus 1, and I multiply that by the LCD, which is x plus 1, multiplied by x minus 1, and remember this is all over 1, right? There's no such thing as cross multiply here. We only multiply the tops of the tops and the bottoms of the bottoms. In other words, the numerators with each other and the denominators with each other. And then x plus 1 cancels, and I'm left with this 1 multiplied by x minus 1. So let's go back. I write down my 1. The x plus 1 cancels with this, right? And I'm now left with x minus 1 as part of the LCD. Right. So I'm going to write that part in. That's equal to 1, so I'm going to write down the 1 that I have there. Okay. The 1 doesn't cancel out with anything over here because there's nothing similar in the denominator. I'm just left with x plus 1 and x minus 1, so I can multiply that out with the LCD times by x minus 1. And then I've got the minus 2x, right, which is part of this. Let me just write it in blue. And the x minus 1 will cancel out with the x minus 1, leaving me with x plus 1. So what does that look like? That's minus 2x all over x minus 1. And I multiply this by the LCD, which in this case is going to be x plus 1 times by x minus 1. So now you can clearly see that all these factors are being multiplied with each other. And when I only have multiplication on top and multiplication at the bottom, then I can cancel these things. So I'm left with negative 2x and x plus 1. Okay, there we go. So let's multiply this out and see what we get. That's going to give me 1 times this whole thing is just x minus 1. This is a difference of squares, so I can put down the minus, and then I just multiply out the first term and the last term. That's going to give me x squared minus 1, and this is going to give me negative 2x squared, right, minus 2x. Okay, now it's a simple case of adding up like terms and seeing where this takes us in terms of a quadratic. This minus 1 and this minus 1 cancels out with each other. If you have to take that to the other side, you get negative 1 plus 1, and therefore that's 0. That leaves me with x squared minus 2x squared gives me negative x squared. Okay. Minus 3x is equal to 0. Now we can just multiply by negative 1 to get everything as positives, and that leaves me with x squared plus 3x. And at this point in time, you can see that things look like it's in standard form. A equals 1, b equals 3, and c equals 0. You can either use a quadratic formula, but it's best to factorize at this point. So I'm going to say 0. There's a common factor of x, and that's going to be x plus 3. Right? Yeah, and that implies that x is equal to 0, or x is equal to negative 3. Now there's something I didn't put in here, and when I'm I should have done it at the beginning. So I need to set that this is my LCD such that x cannot equal to -1 and x cannot equal to +1. Those are the two restrictions I have, right? Simply because this LCD forms part of the denominators in this equation. And if I insert -1 in that, this value becomes 0. Then I have 1 divided by 0, and anything divided by 0 becomes undefined in the real number system. And similarly, if I put in 1 over there, and this is also going to be 0, and then my entire equation is undefined. So when you state the LCD, you must state the restriction, right? And that's commonly forgotten. As you can see, I even forgot it at this point, and I remember to check it at the end. So when you get solutions here, these may be solutions to one part, but not necessarily solutions to the entire equation, and therefore you must reference that against your restriction, right? What x cannot equal. Okay, so that's example number 1.